MatrixSpace has developed a really small cell phone-sized radar that's network connected, software defined. It's a collaborative radar that talks to each other. It's innovative in its size, its cost, and the weight. One of the use cases is airspace management with radar, or working into a fused sensor system with optical radar ADS-B to make the skies a safer place for drone operators and general aviators.
Mission team, we are clear for launch.
Roger, starting pre-flight.
We're going to simulate what we call a BV loss, a beyond visual line of sight scenario. Here we're going to have our partner Census Technologies fly their Santero UAV. They are going to be conducting simulated inspection mission, flying in a lawnmower pattern over the top of our campus here.
This platform is our Santero 5. It's designed to operate in more complex environments and to enable the scaling of future BVLOS operations.
It is a VTOL fixed wing, so we're launching vertically, as you can see here, and when it reaches about 150 feet or so, it's going to transition into forward flight.
During this mission, we're going to be monitoring and surveilling the airspace with MatrixSpace radar. And we're going to be doing that in order to make sure that they're safe and secure with the Santero flight. We're going to detect and track an Intruder aircraft. In this case, it will be a small drone being flown by someone that is unaware of what the real rules are of safe flight. And they're going to be coming in with this UAV through our flight area. And we're going to show how we deconflict that airspace live to keep the two vehicles well clear of each other to avoid any collision in midair.
Hey, ground control, we've got a track on a drone. It's definitely encroaching on our flight area. We're going to want to divert to a loiter and let this drone pass by to make sure we avoid any conflicts here.
Copy, diverting for southwest.
The Santero drone, it's going to divert to a safe position in a loiter, maintain that in a hold pattern until we make sure that the airspace is clear and that Intruder is gone.
In a BVLOS context, the pilot wouldn't have eyes on the aircraft and be able to kind of accurately identify any hazards that might be adjacent to whatever area that you're operating in. So what we can do with this software is you can basically right-click on the map and do a fly to here command and have it go into a simple loiter pattern.
We've actually got two radars surveilling right now. And we got one kind of facing out, surveilling this area, and then one in the backfield, giving a protection area of that inspection route that the Santero is flying.
Hey, ground control team, looks like the skies are clear above us now. That drone seems to have left the area. We're not picking up any more signatures or radar from it, so clear to resume the mission.
Copy, resuming mission.
We'll also have our other partner, Dedrone, who's here with us today, providing additional sensor capabilities with their radio signal detection sensor that they have, as well as their Dedrone tracker software. We're actually showing a first here of MatrixSpace radar integrated with Dedrone tracker. We'll be providing them with live track data of drones as they're in flight, as they're also detecting the drone signatures with their passive radio frequency detector. And then they'll be fusing that information together within their Dedrone tracker software.
MatrixSpace radar is integrated with Dedrone tracker. Here we've got a live radar track on our target doing its surveying. We also have our RF sensor on the roof with monitoring for any emissions from any other drones that might be in the airspace, and it looks all clear. There do not seem to be any intruders in the airspace for our operation.
All the sensors can work together. They have complementary capabilities. Imagine locating it within, let's say, within 10 feet of where it is. And the velocity with better than a half mile per hour, you're developing a track that has an exact trajectory. So you know your own trajectory, and you know its trajectory very well, so you can start saying, what do I need to do to avoid this collision?
Never before has these combinations been able to be available and integrated in a cost-effective manner that makes it affordable. People want to know what's happening and be able to gauge an awareness of what's going on. And that's the game changer. That's what we brought into the table with this cross technology.
Mission complete, heading to land.
Roger that, ground control. Thanks.